Conversations, a series to discuss the ethical and social implications of emerging technologies in health research. And Cultivating Conversations is an experiment of sorts. We have decided that we would like to give people the opportunity who are involved in digital health and AI-related health research to share their research, to share their experiences navigating some of the ethical, legal, and social implications, which is an acronym of ELSI for short. And our goal is to increase awareness of how technologies like pervasive sensors and machine learning and artificial intelligence models can introduce new ethical challenges. And the series presents an opportunity for our UC San Diego scientists and engineers to present their research, discuss these challenges as they've had to plan and carry out their research. And as a community, it gives us an opportunity to learn together, as well as to share our mistakes. And I think this is a really important part of what we're trying to promote, is that mistakes happen, especially in a relatively new field. And not that digital health is all that new anymore. I think it's been going on for, close to 20 years, but really began to take off about 10 years ago, a little over 10 years ago. And I think Dr. Zlatar and I met, I'm going to make a guess that it's been about 7 or 8 years now. So it's my pleasure to introduce Dr. Zvinka Zlatar, who is a neuropsychologist and associate professor of psychiatry at the University of California, San Diego. Her research program seeks to reduce dementia risk by developing novel, real-world digital health interventions that target modifiable lifestyle factors such as physical activity. And then she's looking at how that intersects and affects brain plasticity and cognition. Her research also focuses on early detection of dementia in Hispanics and Latinos and is helping to increase their representation in clinical research. This program, as I mentioned, is hosted by the Research Ethics Program. We do record each one of these sessions. We post the recording on our website, and we also link it to the Recode Health program. And so people who are not here today can join us. And then what we do in about 2 weeks is those of you who are interested in having further discussion about Dr. Zlatar's work with us in person. Our Research Ethics Program office is located at Atkinson Hall on the 6th floor. And we have an open area where we will have a brown bag. And depending on the number of people, we'll either encourage you to bring your lunch or we may buy pizza. And so we are going to go ahead and start the recording. I'd like you to put questions in the chat, but Dr. Zlatar said that she doesn't mind if you'd like to interrupt her and ask your question as they come up. So with that, I will turn it over to you, Zvinka, and we can start the recording start.
Great, thank you. I'm going to share my screen and start the presentation. All right, can you guys see the slide? Great. Well, thank you for inviting me to be here today. I'm really excited to talk about the potential of digital health to improve brain health in older adults and the work that we've been doing in my lab for the past few years. Like Camille said, feel free to ask questions at any time. And I also will pause at some points and just stop to make sure that you guys can ask questions. So the main learning objectives for today are to gain knowledge about how mobile health technologies or digital health and just-in-time alerts can help older adults to walk faster or exercise harder for their brain health when they're doing this independently. I'm also going to try to cover topics to learn more about the older adults' opinions and perceptions of using mHealth in research studies and clinical trials of physical activity. And finally, we will gain some awareness of the challenges of using mHealth with diverse populations. So I think we all know that physical activity is really important for brain health. Lately, there's been a lot of research done in this area where, older adults or people in middle age would go to a lab or a gym, or would participate in group interventions, and that will be supervised. So you would have to have a coach or a health trainer to make sure that people are engaging in the kind of activity that the intervention in the clinical trial wants them to engage in. And there's a lot of research showing that physical activity and exercise done in these ways, in these supervised studies, really translate to brain health benefits and also cognitive benefits that may actually help to delay or prevent Alzheimer's disease and related dementias. So there's a lot of research being done in this area because there is no cure for dementia yet. There's no really successful treatment for dementia. So there is a lot of promise in trying to delay or prevent the disease to begin with. So when I was reading this literature many years ago and doing some studies on it, I really wanted to learn if these benefits that we see to the brain and to cognition in these very supervised and structured interventions would actually extend to the real world when people are just doing free living physical activity. So hopefully, the good thing is that we have digital health to help us answer that question. When people are exercising independently at home or wherever they want to do it, can we see benefits to the brain and benefits to cognition? So I'll just review some of the research that we've done in my lab showing relationships between mobile health devices and brain health. So some years ago, with my colleague, Dr. Cristina Varenga here at UCSD, we collected some data on 52 older adults who were cognitively healthy, with a mean age of about 72 years, mostly women. Usually, these samples are highly educated, and they didn't have any major vascular disease. So it was a pretty healthy sample of older adults living in the community. And we asked them to wear accelerometers. So this little device over here, they wear it around their waist, and we can get, we got a 1 week measurement of their everyday physical activities. They are asked not to change anything, so we can just monitor their movement and then see how that relates to measures of brain health. So all of the participants also underwent a brain MRI, where we obtain measures of cerebral blood flow, or what I'm calling here CBF, cerebral blood flow, that shows how much blood is going to different regions of the brain. So we can actually get a very localized, high resolution, spatial resolution images of the relationship between the activity and the cerebral blood flow. So what we saw was that those who had the higher moderate to vigorous physical intensity activity, or MVPA, moderate to vigorous physical activity, was associated with higher cerebral blood flow in the frontal lobe of the older adult sample. And the frontal lobe is important because it's one of the first to be affected in the aging process. It's one of the latest ones to develop in life, and also one of the ones that starts to, one of the parts of the brain that starts to decline earlier in life as well. So we are seeing that greater, higher intensity physical activity is associated with greater blood flow in this important area that's important for aging. We also saw that all types of light physical activity were also associated with better blood flow in the frontal lobe. And so were the total activity counts that we can get from the accelerometer, which basically just measures the total volume of activity, taking into account intensity and frequency. Interestingly, we saw that the greater the sedentary time measured with accelerometry was related to lower cerebral blood flow in the frontal lobe. And obviously cerebral blood flow is important because it brings all the nutrients like oxygen and glucose that the brain needs to process and perform all the everyday activities, including cognitive activities. So that was interesting to see that physical activity or being more active was related to greater blood flow, whereas being sedentary was related to lower blood flow. We also saw with accelerometer measured sedentary time that people who had more sedentary time, So greater sedentary time was related to this tau protein, which is a protein that accumulates in the brains of people pre-Alzheimer's disease, right? So it's related to neurodegeneration. And even after we accounted for physical activity, we saw an association of greater sedentary time with higher tau protein. And this was using cerebrospinal fluid, so spinal tap, from older adults who were cognitively healthy. So we thought sedentary time may actually be a behavioral risk factor for Alzheimer's disease and related dementias. In a different study with another colleague from UCSD, Dr. Catherine Bangen, we saw that also accelerometer measured physical activity was associated with better memory and better executive function. So we all, I guess, are familiar with memory, the ability to learn new information and recall it freely. And then executive function is one of the aspects that also gets a little bit affected by aging too, in that, it's our ability to quickly process information, to make decisions, and for example, switch from one task to another rapidly, divide our attention. So all of those are going to this executive composite. And so greater moderate to vigorous physical activity, or MBPA, was associated with better performance on tests of memory and executive function. And this was also on people who are older adults, about 72 years, mostly women, who also completed a 1-week measurement of accelerometer at home, and then they did a brain MRI. We also saw that greater MBPA, or the moderate to vigorous activity, was associated with lower white matter hyperintensity volume. And this is a measure of small vessel disease. So when you have this small vessel disease, the vasculature shows these areas that are hypertense on the scans. So you want to have none of those or less of those. And MBPA was actually, greater MBPA was correlated with lower level of white matter hyperintensities. So the summary from these studies, which are just cross-sectional studies investigating how physical activity measured with accelerometry is related to measures that we can obtain from a brain MRI as well as cognition. We found that everyday physical activity that is measured with mobile health technologies was associated with cerebral blood flow in brain regions that are affected by the aging process. So greater physical activity of all intensities, not just MBPA, were beneficial to CBF, with higher CBF in the frontal lobe, whereas sedentary time was actually seemed to be detrimental to cerebral blood flow in the frontal cortex of older adults. We also saw that MBPA seems to be necessary to affect cognitive function and also frank lesions, which are these white matter hyperintensities that I described. And also that everyday physical activity measured with mHealth can help detect brain health in real world contexts. So I guess I'll stop there and see if anybody has any questions at this point that they want answered. No? Okay. So now I'll move over to interventional work. So we wanted to leverage mHealth to help older adults increase their MBPA in their natural environments. And so I got a 23 award back in 2016, I believe, where we did a pilot randomized control trial. And I will describe that here. So it was called the Independent Walking for Brain Health Study. It was a small randomized control trial of exercise where we used mHealth devices to try to help older adults increase the time they spent in MBPA in their everyday environments. So this would be an unsupervised intervention in the real world. It lasted 12 weeks. And the reason why we wanted to increase MBPA is because the recommendations for older adults in terms of physical activity and vascular health are that we want people to be doing 150 minutes minimum of moderate intensity physical activity to actually meet those requirements and maintain a healthy cardiovascular system. So we were encouraging people to, reach or surpass 150 minutes of MBPA. We use an mHealth device to track heart rate in real time. And also the device was able to provide just-in-time feedback to participants when they were exercising at a heart rate that was outside of their individualized heart rate zone that we prescribed for them. So in this way, the mHealth acted as a coach to help individuals with behavior change in real time, so that if they were getting pinged from the device, they were getting a vibration alert, they would know, okay, I need to walk faster or, exercise a little harder to keep my heart rate up so I can stay in this MBPA level for longer. We also had a healthy aging education condition, which was the control condition for this study. They received a reading prescription and different healthy aging topics like nutrition, social isolation, etc. They got weekly quizzes about the materials, and they also received monitoring phone calls from the study staff every month, bi-weekly at the end of the first month, and then every month afterwards. So the physical activity condition, the way it worked is that individuals got a prescription with their individual heart rate targets based on a treadmill test that they did here at ePark. So we were able to have a value for each participant that was corresponding to their own MVPA or moderate activity level. And so then we programmed that into the device so that each device would actually provide immediate feedback to participants when they deviated from their own individualized heart rate targets. They also received the regular phone calls from the study staff, where we talked about barriers to exercise, what they needed, revised goals as needed, depending on how they were doing. They also received weekly progress emails where they had a graph like this that would show 150 minutes in the dotted line, and then where they stood in terms of minutes of MVPA all the way through the intervention that we thought would help to motivate them. So we had 22 participants assigned to the control condition and 21 to the exercise condition. The mean age was about 72 years, and 74% of the sample were female or women. These are the things that we collected. So we got genetic testing data to a certain risk of dementia that we collected at the end of the study. We did a sub-maximal fitness test at the baseline and then again at week 12. We did the accelerometer measurement where they wore the band around their waist for a week, both at the beginning and the end of the study, and as well as in the middle of the study as well. And we did cognitive testing in person at 3 time points. And then we did the brain MRI at the baseline and at 12 weeks again. And the heart rate was monitored continuously through the device. But every time they engaged in an exercise session, they would record it, and then they would share the information with the study team. So this was the device that we used. It's called the MioFuse. It's no longer being produced. And I'll talk about that a little bit afterwards when I talk about my recommendations. But at the time, it was the only affordable device I could find that actually provided these just-in-time alerts that were really cool, actually, because you could program the heart rate. So for each participant, we were able to put their below heart rate, their target zone in green, and then above the target would be red. And then, you could go walk with the device. You didn't need to have your phone on you, so you could just have the watch, and then the watch would track the workout, and it would vibrate every time people deviated from their target zone, as well as flashing a light, letting you know if you were in the red, green, or blue zone. So that is why we used this device. So we had 17 out of the 21 people randomized to the exercise condition completing the actual study. And 15 out of those 17 ended up achieving 150 minutes of MVPA by week 12. And the other 2 participants actually had achieved it the week prior. They just had, for example, one had a planned trip the last week and things that actually interfered, but they did also. So in real life, they all achieved 150 minutes of MBPA by the end of the study. And then 19 out of the 22 completed the control condition. So this is the data from the actual device that we collected. So for each exercise session that the participants were engaging in at home in their own environments, we received a file with minute-by-minute heart rate, and then we extracted for each individual, based on their own heart rate target zones. And these are just the averages across the exercise group over time. So they all started with about 144 minutes of MBPA. Obviously, there was some variability here, but a lot of the individuals were already somewhat active to begin with. And then they went up to 282 minutes by the end of the intervention over 12 weeks. So it was a great increase in the time that they were engaging in MBPA every week. We corroborated this with the research grade accelerometers as well. So when they did the pre and post wearing of the accelerometer for 1 week, they also wore it at the middle of the study. We did see that the control group didn't change their MBPA minutes as much. However, the intervention group had a significant increase in MBPA. So at least we know the data from the device that we chose is somewhat reliable in that sense, that it did match with the MBPA from accelerometers. So what are some of the challenges that we experienced working with this device in the intervention? Well, one of them is that we didn't have direct access to the data. So it was a commercially available device. Like I explained, it was what we could afford and the best option we had at the time. And so we had to ask all of the participants. It was very involved. They would have to record each exercise session on the band and then sync it with their phone app. And then there was a way that a file could be exported from the phone and emailed. And so that's how we got all the workouts from people. They would export a CSV file from their app on their phone and send it to us every time they did an exercise session. And you can only imagine the amount of work we had on the back end to get all the data from each workout for each participant based on their own heart rate target at that point. So it was very, very involved from both their perspective and our perspective as a study team. Using commercially available mHealth devices, they may be discontinued at any point, or they could, which happened to us, they were discontinued, or they can stop supporting the platform or the app. And so there's just all of these challenges that somehow you have to account for, but we really don't have any control over. If there are changes that, there's just nothing you can do about it. So these are just things to keep in mind. So there may not be stability to the actual mHealth device that you're using. In terms of privacy concerns, we cannot be sure how the companies are using the participants' data, even though, we read the terms and we shared with the participants, what types of data they shared or not. We also offered all the participants, if they wanted to create like a fake email address or put fake information into the app and so on and so forth, so that their information wouldn't be compromised. But you just never know really how they're going to be using the data. It was, in terms of the steep learning curve, it was a steep learning curve for our participants to adapt to the use of the mHealth. We did have one participant who dropped from the study just because she didn't like the device at all and she just didn't want to deal with it. So those were, I think, the main challenges that we experienced as part of this intervention. So we did want to learn from the participants about, their experience using this device. And so we did an exit survey with the help of Camille, Dr. Nebeker. And so when they finished the study, we asked them some questions about their experience so that we could learn and improve our future interventions. So in terms of familiarity with mHealth in general, when they compared to others of their age, people were mostly comfortable using technology in this sample. And then when we asked them if they enjoyed using technology in their everyday life, about 85% of them said that they do. So this was not like a tech naive sample of older adults. They were already engaging with technology for the most part. Then we asked them some questions about, this is a paper that actually Dr. Nebeker and I published together using this data from the trial. And we wanted to look at different aspects of digital health. And in terms of access and usability, we asked them different things about, using the device himself, if it was easy to sync the data with the phone. As you can see, not everybody thought it was easy. Did wearing the device help them to walk faster or exercise harder? And that's where I think was really important, because 100% of them did say that the device helped them to change their behavior in real time, which is what we were trying to achieve. Most of them were able to see the lights flashing on the device and also feel the device vibrating. Some of them had trouble starting and ending a workout on the device. None of them reported having trouble finding the heart rate on the device. And then, all of them said that they were easily checking the heart rate during exercise. So in terms of would they wear the device again in the future, actually 60% of them said yes. So a lot of them said that they wouldn't wear this device in the future. And when we asked them open-ended questions of, why they wouldn't do that, some people said the device was hard to use, that they couldn't get it to work. Some of them said that their own motivation was enough, that the device was bulky or it took a long time to sync. We had another participant who said it was not accurate, and this participant would have an Apple Watch and our device, and he would do the workouts with both, and he would compare them, and then he would report back to us that they were not the same, and so it wasn't accurate. And so that's one of these the comments here. Some people learn what to do to maintain their own heart rate, and I heard that a lot from the participants, that after getting this feedback from the device, they kept looking at their heart rate while they were walking and exercising. So they got really good at just detecting when they were in this moderate intensity zone compared to light physical activity. Other people ended up buying similar devices. Technical difficulties were a problem, and the device was cumbersome and not intuitive. Those were some of their opinions about the device. In terms of privacy expectations, we asked them, do you feel it's worth giving up some privacy of your health data for a cause that you believe is important? And surprisingly, a lot of them said that it is slightly or absolutely worth it. So they are willing to give up some privacy of their data for something they believe is important. And in this case was for brain health and dementia prevention. If a fitness app uses my exercise information for research purposes, I would like access to the results. 95% of our participants said yes, they want access to the results. They also, when asked, I believe that no fitness app should share my information with third parties without my consent. Most of them agree that that's the case. Similarly, app developers should de-identify my app data. Yes, most of them said yes, they want the data to be de-identified. When I use an online or phone application, it makes sense to share my name and email address with the app developers. Most of them actually disagreed with this statement. If a fitness app wants to use my exercise information for internal purposes, they need to ask me first. And as you can see, most of the participants agree or strongly agree that they want to be asked permission for how their data is going to be used. If they want to use the information for educational purposes, they need to ask me first. Same thing, they agree and strongly agree. If it's for advertising purposes, this is where they really, really strongly agree that they need to be asked permission. So in summary, from the exit survey, we learned about access and usability, that overall the device was hard to use for the participants. Only 60% would wear it again. But mHealth alerts did end up being helpful for them to walk faster or exercise harder when they were exercising independently. And even with these challenges, the participants saw the value of the device and they wore it, they stuck with it, and they did it. In terms of privacy, they think in general it is worth giving up some privacy for a cause they believe is important. They want access to any results from fitness apps, and they want consent for sharing data with third parties. They don't need to provide consent. In terms of data management, they prefer not to share email or name with the app. The fitness apps need to ask permission to use their fitness data either for internal, educational, research, or advertising purposes. They want to know any results of research using their data, and the data should be de-identified. So I'll just jump into some future directions in working with doing these kinds of interventions with Latinos or Hispanics, and what are the challenges that we've faced. So along with my colleague, Dory Rosenberg over at Kaiser Research Foundation in Seattle, Washington, we started a small intervention, physical activity intervention for older adults. It's called the Pie y a Movernos, or Stand Up and Move. And it was a mechanism that's an R61, R33 funding mechanism. So we had 1 year to do a small pilot study. And then we are just starting now the second phase to do a larger randomized control trial. So in the pilot phase, what we wanted to do is really to do a culturally adapted intervention for Hispanics and Latinos using mobile health to improve their brain health. So in the R61 phase that we are just finishing right now, we wanted, again, to design an all-remote, culturally adapted intervention, physical activity intervention for older Latinos. This is all remote. It's going to be done via telephone or Zoom only. There will not be any in-person visits, because we really wanted to remove a barrier that happens a lot for this population, which is that they may not have transportation to the study site or the time to commute to the study site. So we wanted to remove the barrier. So we did a pre-post pilot study of an initial version of the program with 10 older adults between the ages of 55 and 89. And then we did feasibility. We got feedback on the measures, the intervention content, and the mHealth tools from them. So this was a theory-based intervention. We used also cultural adaptation frameworks that have been published. We convened a community advisory board from the very beginning, and we met twice a year. We had 7 members, and the members were promotoras de salud, or community health, community research workers, researchers who are Latinos, community members, and community organizations, all from Latino Hispanic background. And then we did this pilot study with 10 participants, and then we finished it up with a qualitative focus group to learn from the participants about what they liked or disliked about the intervention, including the mHealth aspect of it. And then now we're finalizing the cultural adaptation to conduct a larger randomized control trial. So the program is remote. We do phone calls or mailings or emails. It'll be done via Zoom as well for the assessments for those who want to use Zoom. We will do some coaching phone calls. We identify support person to help them meet their goals. They will wear the Fitbit Inspire Band for the coaching and to help keep track of their progress. And basically, we just encourage them to sit less throughout the day, find enjoyable physical activities, and getting their heart rate up. So we have 2 steps of the first step to sit less and move more throughout the day. And that just focuses on adding more steps. And then step 2 is once they feel ready to do more MVPA, that they can move to this adding actual minutes of moderate physical activity. So what we found from the pilot, we learned from our community advisory board that we need to have a very tailored and flexible approach with this population, that the goals need to be personalized, that for the Fitbit instructions, we need to really provide a lot of education and support around using the tech. So written instructions, tech education call, which we did in the pilot, short how-to videos for helping people to set up the devices, asking a family or friend for help as well with the tech and setting up the Fitbit. We also learned that phone and text messages work better than email, at least for our pilot population. And so we've had to tweak some of our intervention components to text messaging. And we also know they have very busy schedules. And so we had to, for example, shorten some of our surveys and phone calls and switch around the times that we may be available for calls to be outside office hours, for example. When we did the focus group we did it with 9 out of 10 of the pilot participants attended the focus groups. We are currently doing the coding process, but the main things that we learned in terms of the tech, for example, from the Fitbit band, which they worn on the wrist for the duration of this pilot study, which was a 6-week study. The positives is that they thought it was very informative about the physical activity levels that they were doing. It motivated them to sit less and improve other habits like sleep. So it seemed to generalize to other domains. For example, some of the participants said, "Oh, I really like that it reminded me to drink water, and I could see my sleep score." So they really got engaged with it. Some participants said it was easy and enjoyable to incorporate into their daily routine. Some negatives were challenging to install. They needed a lot of support. Some of the participants, not all, they faced connection issues in between the band and the app, and there was some skin irritation as well. They also wore an active pal, which is a device that you have to adhere to your thigh to measure activity and sedentary time. They wore it for 1 week at the beginning and then for 1 week at the end of the trial. And there were also positive and negatives. In general, they thought it worked as expected. It was easy to wear. It didn't interfere with their daily task. Some would have preferred the device on the waist versus the leg. And in terms of the negatives, we have one participant who the device failed to record, so it was just a wasted effort and time for the participant. We had some skin irritation too, and then difficult to adhere, particularly when it's warm outside. So there were some issues adhering the device to the leg with a tape that we had to send them. So what are some recommendations for improving future mHealth trials? So from what we've learned from all of these trials is that in terms of the mHealth, it really should be something that's ubiquitous and readily available, that will have support and that you will be able to have access to the data and that it won't be discontinued in the middle of your study. Simple and appealing designs, so nothing that is too cumbersome. They should have, for older adults, they should have large buttons and avoid touch buttons where you need to rely on your sense of touch to actually work the buttons. We need to have continued support for the mHealth and also minimal user effort. So, for example, in this trial that we did, they had to start and end the workout, sync it with the phone, and email it to the study team. That was very involved. It was a small trial, so it worked out, but that wouldn't translate to larger trials with hundreds and hundreds of people. And also we couldn't provide that level of support or, IT support for everybody when you're doing a larger trial. And then issues with data access, right? Will you have access to the data? How will you access the data from the device? In terms of privacy, it's really good to read the terms of service of the device that you are going to be using and make sure that the participants are aware of any risk and benefits related to that. They should know who can access their data, how the data is shared, offer to make fake emails or enter fake information so that their own information is not used. And then Dr. Nebeker made a very helpful digital health checklist that feel free to check it out to help guide you in making the decisions when you're selecting a device for your research studies. In terms of trainings, it seems helpful to create short videos just showing individuals how to set up their device, how to track it, how the app works. And also you need to have staff ready to troubleshoot via phone with the older adults. This happens a lot, and it's a lot of time and effort that goes into people just helping with the setup and tech issues that come up. Ask the participants about their comfort level with tech, because some of them are really comfortable already, and you may not need to do a tech phone call with them. So it's good to know from the get-go how comfortable they feel. And then maintaining regular contact too with the participants. In terms of feedback, it's good to have real-time feedback from the mHealth. It really did seem to help participants when they saw that the device was acting like a coach and telling them to, or reminding them to exercise a little faster, or, walk up a hill instead of staying flat. And they actually did improve their MBPA based on those just-in-time alerts. Also, it's good to give feedback to participants and also get feedback from participants so we can continue to improve our trials and the devices that we use and how we use them. So we're almost there. A summary overall with regards to the learning objectives. So the first objective was to gain knowledge about how mHealth and just-in-time alerts can help older adults walk faster for their brain health. And we learned that mHealth and just-in-time alerts can help to increase MVPA by 95% over 12 weeks, at least in this small trial. Although the device was not easy to use and it was not the favorite for participants or the study team, it did help to change the behavior in real time. So I can only imagine what an actual appropriate device for this population could have helped them to do. Overall, mHealth was helpful despite all these challenges. In terms of older adults' opinions of using the mHealth in research studies, there were some privacy concerns, some concerns about the accuracy of the devices, the usability, and access to the data, who's accessing it and for what. They want to know what is being learned about them, and they want control over how their data is being used. And gaining awareness of the challenges of using mHealth with diverse populations, we've learned that we need help setting up devices. So we did spend a lot of our resources and time, staff time, setting up tech phone calls with participants to help them set up the Fitbit. And listing loved ones to help with the tech. That's something we're going to adopt for the larger trial, where from the beginning, we're going to ask people to identify a loved one. It could be a daughter, a son, a friend, a partner that can help them with all the tech aspects at home, so that we will then be ready to help those who need it if it hasn't worked out with the loved one or with the tech videos that we will be making. We learned that we need to be more reliant on text messaging than email, that we need a flexible approach, flexible hours. But once the tech challenges are surpassed, the use of the mHealth devices was very helpful for our sample of older Latinos. They really, really enjoyed it. So once they just got past that setting up and understanding how it worked, they really, really loved it. So I'd like to thank, obviously, all of the staff in my lab, all of my collaborators, and the funding sources. And I'm happy to take any questions.
Zvinka, thank you so much. This has been just a really wonderful, comprehensive picture of your work and how much effort you put into the design and learning from people who you will be working with, which oftentimes there's no money for that. the depth of work that you do with the promotoras, with the community members. So is there a part of your funding mechanism that has allowed you to do this prep time, or is it something that you build into your proposals to make sure that you can do the work that is so important to the success of your recruitment, enrollment, intervention delivery, all of that?
Yeah, it's really hard because I think one of the things that we tend not to budget for when we write grants is recruitment, outreach, and qualitative work, right? So those things are usually not budgeted in, but in my case, like we're budgeting for those things because otherwise we couldn't do this work. In terms of the promotoras and everything, we did a budget for that, and we have people in our team whose whole job is to do recruitment and outreach and work with promotoras to reach out to participants. And then for the PIA Movernos study, this new pilot study, we did have that 1 year of pilot work where we built in the focus groups and the reiteration and translation costs, because we really do want to culturally adapt the intervention. So we needed to learn from the participants and from the members of the community advisory board, who we also budgeted for them to receive incentives and compensation for their time. So, I mean, we take it seriously. We really want to learn the barriers for this community so that we can try to break those barriers and increase their participation in research.
Well, thank you so much. We've got a couple of questions in the Q&A, and I'm going to turn that over to Ramona in just a second. I am really picking up on how much work you're doing to get the device working for people that are going to be using it, and how much value you could be for some of the tech companies. And I guess I'm wondering, like, it shouldn't be that hard. And I'm thinking that, that data that you're gathering is so valuable. And I just want to plant the seed that you should be thinking about how you might want to convey that to a company, because it's a huge value. And the other question that I had, where you said, people really want to know what you're learning about them. How is it that you're sharing information back with people? And is that part of something that you're testing? What works? What do they want? How much do they want? What format do they want it in? And then Ramona, and then Brittany.
Yeah, I mean, that's a great point. Unfortunately, I haven't had the resources with my K23, the first intervention that I described, to share the data back with the participants. But in this new study with the Latinos, our plan is to, we have a newsletter that we're going to have, and we're going to send quarterly updates to all of our participants. And then we also sent them at the beginning of the study a bunch of materials via mail, and one of those was just like bios and pictures of all of the study team members that they would, that are involved in the study, so that they would they would feel more familiar with us. For other studies that I do with the Latinos, collaborating with the Alzheimer's Disease Research Center, we do participant appreciation events. In fact, we're planning one right now where all of the Latino participants are going to be invited, and we have people give talks about what we have been learning from their data, and I think those are very well received. But obviously, they take budget, they need money and time and a lot of preparation. But yeah, I definitely do think about that, because I know that people want to learn why they're doing this, right? We can explain all we want at the beginning, like, oh, for your brain health and for your family and for dementia prevention, but it is a different level when they actually see how this is being, the implications of the research and what we're actually learning in a bigger picture.
That's terrific. Ramona?
Thank you. So you answered one of my questions about the returning results to participants. And I have a couple of questions that are very different. One of them is, if for the study with the discontinued fitness tracking band, you mentioned that there was a genetic screening component. Do you have any data or results about the benefit of the physical activity to people with known genetic mutations that are associated with dementia?
Oh, okay. Well, there's a lot of research studies on that. So sometimes, well, it depends on what outcomes you're looking at. But I only collected ApoE4, so it's just one gene that increases the risk of someone developing dementia. So it's not an extensive genetic profiling of any kind. And because I have a sample that is so very small, I can't do any analysis comparing like the ApoE carriers with the non-carriers. So I don't think I have an answer for you, but there are studies of physical activity that do show, for example, that people with mild cognitive impairment, which is like a pre-dementia stage, for some people may benefit differently from physical activity interventions. And they may need more frequent, but shorter exercise times. And so, there may be different prescriptions, for example, that you may give to people in different risk stages. But all of the participants in all my studies are cognitively healthy. I hope that answered your question. I don't know if it did.
Yes, thank you.
Brittany, do you want to ask your question?
Yeah, thank you so much for your presentation. I had a question about the active follow device. So I know you mentioned in your pilot study with Dory that you had a pre and a post wear, right? And so I'm curious if the participants were able to see any of that specific data related to their sitting time.
Yeah, like if we shared it with the participants? Yeah, I think, no, we didn't share the active pulse data, I don't think, in the pilot. We did share always like the Fitbit data, and so the health coach would review the data with people during the coaching calls using the Fitabase like weekly averages. So that at least there was some numbers backing up the health coaching calls. But we did talk about, I'll have to get back to you on that, because we did talk about sharing the results of the active PAL. And I just don't recall at this moment if we actually ended up doing that or not.
Yeah, no, I'm familiar with the software. I worked on a PL1 with Dory a couple years ago. And so looking at that data, the output that the software gives you, it's not in a good format for participants to understand. But what we did is we took that data, ran it through R, and made it real appealing. And then in that intervention, we were able to, for the first several weeks of the intervention, show participants on a weekly basis that feedback with that format. So if Dory hasn't shared that with you, definitely ask her about it, because it might be worth a larger trial.
Yeah, I mean, we worked together on this study. So, I mean, and I think you're bringing back like the memories to me, because we did have this conversation. We were like, what can we share with them? We want to share as much as we can. And then we were looking at the output that we got from the active file, and we were like, this is not really helpful or easy to understand. And I believe that's why we may not have ended up sharing it. But we definitely had this conversation. So it's good to know. And I'll make a note, and I'll write down your name to make sure I'll tell Dory that Brittany York told me that you guys have
she might know me as Lors. My name has changed since then, but yeah, she'll know who I
am. Okay.
Thank you.
Thank you. That's a really good tip.
And I noticed on the registration there are many people who have registered that are people who are doing digital health research, and there are people that are interested in learning how to do it but not yet doing it. So I just want to let those of you know who are here who haven't done anything in digital health research, this is a place where it's a good place for asking questions. And as you can see from Zvinka's work, we don't have the answers. And so engaging participants and trying to figure out what's going to be acceptable, tolerable, what cultural concerns can be brought into factoring in whether somebody's going to use a technology. I mean, this is a great place to ask those questions. So if you have them, please feel free to talk about that. Raise your hand. And I see that, I think, Ramona, you had a comment in here, or question, do you have protocols for sharing research results with participants in your study? And I think, Zvinka, you were talking about things that you're doing through the newsletter, different presentations, which are really important. I think that kind of engagement helps to build capacity and helps people who are involved in research know how group level results are showing up. And people also want to know how they're changing as individuals and what you're learning about them over time. And have you thought about, I mean, it sounds like you're doing some work toward bidirectional group level engagement, but what about individual level? And have you put a protocol in place? Are you thinking about it? If you were thinking about it, have you gotten any pushback from maybe an IRB or even the funders?
Yeah, I think that's something I always think about, and we've talked about also with other study team members, is I really want to share as much information as possible with participants, especially if we have any health-related information that we gather that, for example, the Latinos or Hispanics may not have access to otherwise, and that may be helpful to them. But then every time we have these kinds of conversations, so many other ethical issues pop up that it just kind of freezes you because you don't know how to move forward. So, for example, when you're talking about cognitive function and do you return, results to participants about their cognitive performance, there are obviously a bunch of implications of, what if someone has mild cognitive impairment on our testing or, may have dementia, they're not doing well. How do we do that? And then reporting or letting the participant know, but if you don't have a resource to send them to for help, then, that is just the issue that always comes up. Or sometimes with biomarkers of Alzheimer's disease, do people want to know that? There is no cure. Some people may not want to know that. So it's like, well, maybe we give them the choice. Do you want to know that? Yes or no? Some of the biomarkers that we collect are not, for example, ready for clinical use. So they're really research-based, and there's no really way to translate it into, or to say, yeah, if you have this biomarker is high, for sure you're going to develop dementia, right? So it's
right.
Just very gray area.
It's right for research. And I just realized we're only a minute away from needing to close our seminar. I want to remind you all that we have a brown bag discussion in person, in real life, 3D, in 2 weeks. And so, Zvinka, thank you so much for bringing your research to us, for sharing your processes, thinking through how to do this ethically and responsibly, and learning from each other. So we really value your contribution and look forward to seeing you and others in a couple weeks. If any of you have recommendations for speakers or would like to be one of our speakers, let us know. And until then, we will see you soon. And thanks for being here. Take care.
Thank you. Bye.
Thanks, Zvinka. Great talk.
Thank you.